Welcome to Mining Now. I'm your host, Jared Downey, and we are still producing episodes and bringing you episodes from Australia for our third annual Australian tour. Today we have back on the show, we were talking about it off air, almost a year to the day. We've got Glencore Technology back. We've got Rebecca McKechnie, metallurgist at Glencore Technology. Rebecca, welcome to the show.
Thank you, Jared. It's nice to be back.
I feel like we need, when people return, we need like a little clap effect when people come back, welcoming them back.
That would be nice.
You told me something kind of crazy when we jumped off. You're packing your bags, ready to go. You're moving your whole life to Canada, to Toronto, and you just had to come in here to do this interview from you're in Brisbane, right?
Yep, so last day in the office today, and I have come in specifically to do this interview, and I will fly out tonight after we're done.
Wow, and that's going to be, what, like a 20-hour flight, 22 hours?
Yes, it will be. So wow. A decent layover in Hong Kong before I then head into Vancouver and then head upwards, but it will be nice to be back and to be in the region to work with a lot of people who'll hopefully be listening to this interview, actually.
For sure. You're landing in Vancouver. You could have, in between flights, just jumped over to the studio, done a quick in-person.
Easy.
Rebecca, we're going to be talking about the Jameson Cell. So I had to do a crash course on it. A lot of people in the industry will know about it, of course, but I was going through the website. There's a really good video just sort of showcasing it. Can you just introduce it to the audience for anybody who doesn't know what it actually is and how the technology works? And then we got plenty of stuff to cover after that. But I just wanted that sort of brief overview first.
Absolutely. So we'll sort of talk through this video, but obviously you can see it on our landing page. We start by comparing a conventional tank cell circuit to the sort of equivalent in Jameson cells, and we'll talk a bit about that shortly, but basically the video moves you through the cells themselves as well as the equipment, the ancillary equipment that's required. So starting off with the pumps that actually feed the Jameson cell and sort of doing a walkthrough of each of the levels, moving through some of the discharge tanks and then up to the cells themselves, mainly to show sort of the points, that the two different cells in this rougher scavenger setup, the actual feed line leading up to the slurry distributor, and then the way in which the slurry will be distributed into the cell, and pointing out some of the key characteristics. So the wash water available in the Jameson Cell, which helps us to achieve premium grade. Obviously, the actual design of the slurry injection circuit, if you will, the downcomers, which is how we create very fine bubbles and push or force a bubble particle interaction to essentially remove the consideration for residence time when designing these circuits. And we'll talk about that a bit more shortly, but you'll see the very tumultuous mixing zone that's formed in the Jameson Cell, which is really sort of the underpinning of its whole design and why it's so successful, and its ability to recover across a very broad size range. And then moving through, as we slowly get to the next part of the video, what you'll see is the recycle mechanism for the Jameson Cell. So one of the key characteristics to this is keeping the pressure to each of the downcomers or the slurry distributors quite constant. And so the Jameson Cell has an inbuilt recycle mechanism. It will recycle part of the tails, and that percentage will vary depending on how the feed to the cell varies, and allow for that consistent operation and that consistent pressure to maintain the velocity that we need in the slurry jet, and therefore that mixing and the fine bubbles that are generated.
It's a very good. It was a very helpful video for me because I needed to, like I said, I needed to do a crash course. We should clarify again. A lot of people are going to be familiar with it, but for anybody who's not, this is not some new technology. This has been around for I think 40 years or so, right?
Yes, you are absolutely right. So nearly 40 years the Jameson Cell has been in existence. So we're sort of at the stage where we have more than 500 installations sort of internationally. And as you can imagine, over that time from its origins, we've had a lot of time to continue to improve and develop the actual design itself. And so we've sort of seen it move from its origins, which were typically in cleaning, through to new applications in roughing and at the front end of circuits as well, and the design of full concentrators based around Jameson cells.
Let's talk about our heavy industry tour brought to you by Orica Digital Solutions, leading drill and blast into a new era with next-gen Shot Plus. With market-leading design tools and predictive modeling capabilities, Next-Gen Shot Plus equips drill and blast professionals to effectively improve blast designs and achieve optimal outcomes. Click below to learn more about Next-Gen Shot Plus. We are heading to events across North America and Australia and filming episodes on location. Email us at info@crownsman.com to be part of Crownsman's Heavy Industry Tour. As heavy machinery specialists for mining, SMS Equipment knows performance, like the performance they achieve together in a partnership dedicated to the success of their mining customers. At SMS Equipment, they're more than machines from trusted brands. They're the people beside you today and every day, bringing industry-leading technology and expertise to your mining operation. Because the right partnership makes everything possible. SMS Equipment, partners in your possibilities. Discover what's possible at smsequipment.com. OK Foreign Trade and Mining Company is the leading producer of injection chemicals from the mining and tunneling industries. What distinguishes OK is that all processes are managed entirely in-house, from the production of raw materials to research and development and sales. This vertical integration ensures that injection chemicals are tailored specifically to the required needs. The products are utilized for strata stabilization, roof support, and the prevention of air, gas, and water leaks. A commitment to quality is demonstrated through accreditations from NAC, IAAC, APAC, and ILAC, ensuring that all tests and products comply with the highest international standards. Visit okdtm.com to learn more. The mining industry is evolving. Efficiency and sustainability are more important than ever. Drawing on decades of expertise, Aderco's innovative fuel additive enables you to decarbonize your operations without sacrificing performance. Lower emissions, protect your engines, and save on fuel expenses, all with one simple solution. Choose Aderco, the smart choice for sustainable, profitable mining, because you can save money while making a positive impact. Visit aderco.com to learn more.
Has that provided any challenges in the, just within the industry, saying, well, this is for the rougher part, not just the cleaning?
It absolutely has. So, as I said, because its origins were in cleaning and it became so well known within that duty, it's been a really big challenge to actually show people that no, it's not just suitable for a cleaning circuit. It actually works very well in a roughing capacity as well. And so we have started to design and commission these Jameson cells that are now in roughing capacities. We have a full concentrator, and as we start to share that data with people, I think that mentality it's slowly changing, but we really need to do more to show people what we've done and what the Jameson cell is able to achieve in that capacity. So as we commission more, and we've got data from sites like Cadia and Aerocopper, the more that we're able to start showing this to people, to showing what it's able to do and to prove that it works, the more we'll be able to change that mentality. But it has been a challenge to start with, as is anything new in mining.
Well, you said there's like 5 questions I'm trying to remember in my head while you're talking. You said that there's about 500 units globally. Would 80% of these be for like the cleaning side, or would just roughly? Would it be split? What do you sort of think?
I can't give you a rough number, but I can say that given 40 years where we started in cleaning, yes, the majority have been in cleaning circuits, but progressively we're actually seeing that percentage change, and we're seeing the percentage that are applied in a roughing capacity increasing as people realize and see what it's able to do.
And again, I'm trying to make sure I don't miss anything, because there's a couple of really key questions I want to ask. And now, does the technology change from one unit to the other, or has it changed? Is there like 2 different streams now that the rougher design?
No, the basic function of the Jameson cell is still the same. It has been obviously a progressive change to parts of the design over many years, but just as we've applied these cells and compared them to conventional units, what we've seen when we've compared them directly, we've seen the Jameson cell perform very well in terms of fines recovery because of the high shear that the slurry jet creates, and nice fine bubbles. We've always known that it's it's excellent at fines recovery, but when we've been doing direct comparisons, what we've also seen is that, in fact, the Jameson Cell is very effective at recovering particles, even at the coarser end relative to a conventional cell. So I'm talking about up to about 300 micron. And so looking at that and seeing that opportunity for sort of roughing and cleaning, we sort of see the opportunities for brownfields operations in terms of putting these in to increase circuit capacity, but we're also starting to see those potential opportunities for for historical sites, old tailings, where we know that the use of conventional tank cells did mean that there were a lot of particles that went missed that are now sitting in those tailing deposits, and we have a sort of a new technology here. 40 years new, that can be applied. So the opportunities are quite endless.
Make the most of your broadband network by adding mission-critical voice with Tasta's PTT. Trust Tasta Americas for flexible solutions that fit your needs and integrate seamlessly with data networks and devices. Take advantage of your existing broadband network such as LTE, 5G, and/or Wi-Fi to provide secure, reliable voice communications with their on-premise solution. Tasta Americas, your communication and safety partner. Visit TastaAmericas.com or follow them on LinkedIn to learn more. Techway designs, manufactures, and services high-quality industrial scales and feeders. For over 50 years, processors of everything from French fries to frac sand have counted on Techway to provide the most durable, accurate, and reliable in-motion feeding, weighing, and metering equipment for their dried material handling needs. They specialize in providing tailored solutions that endure the test of time and material. Techway's quality line of products are proudly made in the USA. Learn more at techway.com. In heavy machinery, uptime is crucial. Meeting productivity demands with less downtime requires top-notch lubrication. The SKF Lincoln SL6 metering device is built to excel. With a proven design, it handles even the toughest conditions, ensuring reliable performance with extreme pressure greases. This automatic lubrication system reduces maintenance, cuts grease consumption, and extends component life. Plus, its advanced sealing technology minimizes leakage risks. For those who demand reliability, the SKF Lincoln SL6 delivers superior lubrication. Keep your machines running smoothly. Visit skf.com/lubrication to learn more.
That's a whole other episode. The using the tailings. I've had so many off-camera interesting discussions with so many different people about it. I need to get like 3 or 4 people on a panel to actually discuss what that industry potential is, because it's a very interesting, but not necessarily a consistent feedback that I get. Because some people, of course, say, yes, this is a great business case, but then there's things about permitting. And anyway, it's all going, very interesting topic.
A can of worms.
It's a can of worms. That's exactly right. The Cadia and the Euro, I don't know if I'm saying those right, but those two projects, do you have an idea of what the comparison, like you said about electricity, the footprints are really one I'm really interested about. What would a comparison standard design, and we are going to do another episode with Glencore actually comparing some of the technologies, but just roughly, what would that look like in a normal upgrade with a standard flotation circuit?
Yeah, that's a really good question, and obviously that will vary project by project. But we've got plants that we've designed and direct comparisons to conventional alternatives, as well as sort of an independent study that we had done by Asenco to compare a circuit that they designed to a demo concentrator. If we look at the Hudbay New Brick concentrator, they were originally looking at 11 tank cells, and they have replaced that with just 4 Jameson cells. And so that was about a 50% reduction in potential footprint for that project. And we've got another one in the CIS, so again, a full Jameson concentrator for that one, and that was 19 Jameson cells to replace 63 conventional tank cells.
19 to 63?
So again, these reductions in footprint of anywhere between sort of 40 to 60% that can be achieved, because as I said, the Jameson cell a single Jameson cell is capable of replacing several tank cells.
Wow, so that's, and when you're talking about a footprint, yeah, like you mentioned earlier, you're talking about the concrete you need to pour, the building, and then energy is even less of a consumption as well, right?
Well, that's right, because as I said, the Jameson cell doesn't have any moving parts in it. So there is a pump that will pump the feed to the Jameson cell, but then within that, there is nothing more. So from that perspective of power, even from that perspective of spares, so the OPEX associated with your maintenance and spares, substantially lower.
I want to circle back. When you're having a discussion with people, like obviously you have major minds as case studies, so there's really no questioning the technology. What is sort of the challenge you're still running into, though? Is it just a knowledge base, or what are some of the reasons, or maybe to expand on that, what are some examples where it doesn't fit?
Realistically, when we're looking at the Jameson cell, it's suitable for a broad range in feed variations. It performs well in roughing and scavenging duties, and looking at test work, or when we compare like for like, your Jameson cell should be able to achieve the same results as a conventional unit. Again, each project is unique and should be looked at accordingly, and we would always encourage people to look at the full spectrum of technologies that are available to them. But realistically, if a conventional tank cell is able to achieve it, a Jameson cell should be able to as well.
And so, what is your role within the company? Like, what's your sort of day-to-day within in relation to the Jameson cells?
So I am one of the solutions metallurgists here at Glencore Technology. So basically, we exist as a team to work very closely with our clients or potential clients to understand their unique needs for their operation or for their project, and to tailor solutions directly for them. So we're looking at what opportunities exist within their circuit, what they need to do to treat their unique ore or concentrate, and whether the technologies that Glencore owns might be suitable for them. And so that spans, obviously that is inclusive of the Jameson cell, but of the other technologies that Glencore owns as well. So that's the Jameson cell, the ISOMIL, the Albion process, ISOKID, and the ISOSMELT. So you can see from that we actually span the spectrum of processing, ranging from sort of your front end concentration through to aspects of comminution, and then downstream treatment, so oxidative leaching, smelting, and then the ISOKID that I mentioned is your copper cathode plates.
So, and you're involved with all of that?
The solutions metallurgists work across the spectrum of the technologies, that's right.
Okay. So now I get to ask this fun question. So in those discussions, I asked in a way that's like, why wouldn't you use it? But I'm going to ask similar question, but in a bit of a different approach. What are the questions that you're fielding? I do now hundreds of these interviews, and I'm sure there's people sitting on this watching going, this is what I need to know, and you're asking every question but that. What are some really key questions that you're getting from people that are also in your field on the operator side, that are key questions to making sure it's the right technology, it's got the right capacity, all those things? What are some of the questions that you're fielding?
The key questions that come to us, it really is it as good as you say it is? That is what comes to us. Will it really save me money? And what do I need to do to have one of these, or to run one of these? What's the catch?
Right.
From that perspective of what people are looking for, obviously they are looking for confirmation that what we are providing will be of benefit, not just in terms of the grade and recovery, but what is the true operating cost and what is the true capex. And we are always happy to share information. So we're very transparent, happy to share information about that and about our products, and how they compare to their conventional counterparts. From that perspective of, well, what do I need to run it? That is something that's very important to consider. Obviously, for our clients, we work across the spectrum, from junior miners to your more senior companies, and in some very interesting and remote locations. So they're obviously looking at what they need and whether this will fit in within the constraints of their unique project. And I suppose part of the benefit of the Jameson Cell is the simplicity of it, the parameters that you need to watch or control in order to make it run well. And that is, for some of our sites, a key consideration, because it is very straightforward and very easy, and depending on the workforce from which they're able to draw, this is actually a very appealing option for them, because it is so simple to run.
What is, when you're having those conversations, one of these days, someone's going to let me be a fly on the wall with a camera sitting there and actually hear these conversations. But once you walk them through, is it pretty clear to most people? I mean, obviously, not everybody, maybe they've already committed to something else or whatever the reason that someone doesn't go with it. But once you go through it, is it pretty clear to most people in the industry that this can fit and it is doing what you're saying? Do you have enough data to answer that question?
Yeah, we have a lot of data, and as I said, we are very transparent with it. So I think we still need to do a better job of making sure that we get that data out there. Obviously, it is it's a simultaneously big but very small industry.
Yeah.
But we're always happy to share data to share with people what we're working on, what we've sort of recently commissioned, and how well that's doing. Like I said, it's always very well received, but it's always received with there must be a catch. And I think that does come back to how long established conventional tank cells are. So
Right,
they've been around or been in operation for more than 120 years. I think we've all either learnt about them or operated them, and we're familiar with them, and it's sort of the safe default, if you will. And so
Right.
sort of changing that mentality, even when there's data, it is a challenge, and particularly in an industry that's so risk averse.
Do you, with the, in like the bidding process, when people are, I guess it's also that's a relationship you have or the awareness even with like engineering firms that are working with these companies, because I would imagine you've run into cases where they don't use the Jameson Cell as part of the original design. And if they don't use it now, you've got to get them to rework that. Is that a much of a hurdle, or is that a fairly easy thing? If an engineering firm realizes, oh, this is a better option, is it a hard thing, or is there a lot of money that needs to be invested in sort of that redesign?
From that perspective of actually considering a Jameson Cell, even within the context of a project that may be a little bit more advanced in terms of that design, that's relatively straightforward. If there is existing flotation results or mass balances, we're obviously able to provide input, so sizing and costing to the engineering company. And we work with a lot of different engineering companies and work within their requirements, but very easy to be done even with existing flotation tests and mass balances. We'd always encourage then applying the sort of the testing that is specific to the Jameson Cell. This is, however, very easy. So if we had a project that was towards those more advanced levels, and we do have some of these towards the end of their PFS study, we've sort of jumped in and they've looked at and considered it. And this was a sort of straightforward approach of commencing with their existing test work and mass balance, and then adding in what we call the 3-stage dilution test. So that's the test, the bench scale test for a Jameson Cell. It's performed in your standard Denver float unit, in such a way that it simulates the effect of the wash water, and we generate a grade recovery curve along which a Jameson Cell could be operated. And from that curve, that actually scales 1-to-1. So we can design a Jameson Cell off this very simple bench scale test. The bench scale test is freely available. Any laboratory that does flotation work can have this test procedure and can perform it completely independent of us. We've got sort of nothing to hide, and from there it can actually easily be incorporated into the existing design for a project.
Have you seen, like in the Katie example you mentioned, they're increasing their circuit capacity.
Yeah.
Have you seen cases where, or is there ever a case where they would add in the Jameson Cell and then go, okay, we're actually going to swap out and go fully to the Jameson Cell, or would that not really make sense if you've already got...
I would never say never. So when we were
course, yeah.
with our Mount Isa site, we obviously had a sizable cleaning circuit. So just to your point of existing circuits, a sizable cleaning circuit. The tank cells were old and run down, and obviously the cost of refurbing them was going to be quite significant.
I see.
So yeah, what they actually did was sort of shut that bank of cells down and replace what was quite a large footprint with just 3 Jameson cells to replace the whole cleaning circuit. So I suppose it depends on the sort of the stage of a project, the state of the existing equipment, sort of other constraints around their capital and what they might have, and that comparison of sort of refurbing existing cells to putting new ones in. But it is something that could be looked at, the replacement of existing conventional cells with Jameson cells.
Before we wrap up, I wanted to circle back to just the testing part of it, because you said that is the big question. So what are the mechanisms in place that people can get the testing, make sure that it is the right fit for their circuit?
Yeah, that's a really good question. And so we touched on that that bench scale test, which is the 3-stage dilution test done in a standard Denver cell, that again, any laboratory with flotation capacity can do. Then moving on to the next stage, and sort of depending on whether we're talking about a greenfields or a brownfields operation, we have these test rigs that are actual Jameson cells. They're just single downcomer Jameson cells. But we have the L150, which is a laboratory scale one. And there's L150s around the world in different laboratories. And these are laboratories that are independent to Glencore Tech or Glencore. So they own these rigs, sort of no specific affiliation with us. They are there to perform this test work and provide results. And similarly, we have a site-based rig. So this is a rig that can actually go out to site. It's plug and play. Site gets it, plugs it into the circuit, plays around. Sort of there's a test matrix with different parameters, and they're able to evaluate what the Jameson cell can achieve for them. Now, obviously, we will go and provide support in the sense that we will show people how to use this rig on site, and then we leave it up to you. So you're able to play around with that, see what you're able to achieve. But the point here is that we've got these options that can be done independently from us. So we don't need to be there. We're always here for help. But just to make sure that people can see how well this can work, what it can offer for them via sort of an impartial medium able to provide it.
That actually reminded me of another thing that I was going to ask that I forgot to, is the capacity range. Obviously, you said that you bring up the lab, so there's testing, and then it scales up to then where you just start bringing in more units. So what is that range within?
So with the we've got those 3 that I mentioned. So in a Denver cell capacity as per whatever each laboratory cell will hold. We have the L150 in a number of laboratories, single unit. Typically, we run in batch, but could run it continuously. And in that respect, we're looking at anywhere from 13 to 20 kilos a time to run, versus then moving into your Z500. And again, usually it's sort of a single unit that is plugged into the part of the circuit that you're looking to test, but that one runs continuously.
And then you just scale based on how many of those you need. And
these all scale. I will point out that these all scale. It's a 1-to-1 scale up from any of those.
Okay.
From the 3-stage dilution test, from the L150 or from the Z500, 1-to-1 scale up. So once we see those results and we generate the curves, the grade recovery curves from those, we can then size your full JAMO.
Perfect. Okay, well, I'll leave you just with one. As you're moving to Canada, I'm just going to ask you, we were talking about it off air, how much do you like our coffee? Like Tim Hortons, these amazing brands of coffee that we deliver to the world.
You know my response to this. I'm going to have to search very hard in Toronto to try and find a decent coffee place, or at least maybe bring some Australian coffee over there.
It must, because every Australian just goes so hard, to borrow an expression, hard in the paint on our coffee. I'm like, how bad is it actually to drink?
I have no comment. I am not going to say anything before coming to my new home country. So
yeah, well, it's good. Well, great to have you. Welcome. Toronto is a fairly good-sized city. There's somebody somewhere making a decent cup of coffee. I hope you find it. It's going to be some little Greek restaurant somewhere. Find in the back. So welcome, safe travels. You're literally flying out, I think you said, in like 10 hours. So safe travels. Thank you for coming in just to do this. Great to have you on. I'm sure we're going to do it again. We'll probably do it again somewhere on site in Canada.
Absolutely. I look forward to it.
Thank you very much.
Thanks, Jared.
You can connect directly with Rebecca on LinkedIn. You can follow, of course, Glencore Technology. All those links will be on the website. In the description of the YouTube video or tagged on LinkedIn. Thank you for watching, everybody. Please make sure to subscribe, and we will see you on the next episode of Mining Now.